Linear inequalities. These are the steps for solving linear inequalities. Please pause the video and read through these steps before we explain them. The solution to a linear inequality will be a shaded portion of a graph. The shaded portion represents all the points that make the inequality true. The dotted line is not included in the solution set. If it is a solid line, however, it is included in the solution set. Dotted line not included, solid line is included. Solutions to horizontal or vertical line inequalities may look like these. In either case, the shaded area represents the points that make the inequality true. Let's start with some examples. In example 1, y is greater than 3x plus 2, we already have slope-intercept form. To graph this line, begin with the y-intercept of 2. The slope is 3 over 1, up 3 and to the right 1. Now graph the line. Because there is no or equals under the inequality, this will be a dotted line. It will not be included in the solution set. The next step is to determine which side of the line should be shaded. To do this, we need to test a point. If this point makes the inequality true, we shade on that side. If it makes the inequality false, we shade on the other side. The point we're choosing is 0, 0 because it's easy. Plug in a 0 for y and a 0 for x. This gives us the inequality 0 is greater than 2. Well, this is a false statement. 0 is not greater than 2, so we do not shade on that side of the line. Instead, we shade on the other side of the line. The shading represents all the points that make the inequality true. We do not shade where the inequality is false. Now pause the video and try the next example yourself. Now that you have tried it, check your work. Once again, we start by graphing the line. The y-intercept is 1, the slope is down 2, and to the right 3. This line will be a solid line because there is an or equal symbol under the inequality. A solid line indicates that the line is included in the solution set. Next, we need to test a point to discover which side to shade on. If this point 0, 0 is true, we will shade on the same side as it. If it is false, we will shade on the other side. Plug in 0, 0 into the equation. This gives us 0 is less than or equal to 1. This is a true statement. 0 is less than 1. This means that the side of the line that includes 0, 0 is the side where all the points make the inequality true. We shade this side of the line. Everything in the shaded portion of the graph makes the inequality true. The shaded portion is the solution set. In example 3, the line needs to be converted to slope-intercept form before we can begin. Subtract 5x from both sides of the inequality. We now have 3y is greater than or equal to negative 5x minus 18. Now divide all sides by 3. This gives us y is greater than or equal to negative 5/3 x minus 6. Graph the line. We begin with the y-intercept at negative 6. The slope is down and right, which we cannot do with this graph, so we will go up 5 and left 3. Up 5 and left 3. The line will be a solid line since this was greater than or equal to. It had the equal symbol under the inequality symbol. The next step is to test a point to see if it makes the inequality true. Once again, we use 0, 0. Put in 0 for x and y in the original inequality. This gives us 0 is greater than or equal to negative 18. A true statement. 0 is greater than negative 18. So we shade the side with 0, 0. All the points in the shaded area make the inequality true. That means all the points in the shaded area are the solution set of this inequality. Now pause the video and try the next example yourself. Now that you have tried it, check your work. Begin by converting this equation into slope-intercept form. Subtract 7x from both sides of the inequality. This gives us negative 6y is greater than negative 7x minus 24. Now we need to divide both sides by a negative. Remember that when we divide by a negative with inequalities, we must reverse the inequality, giving us y is less than positive 7/6x plus 4. Now graph the line. Start with the y-intercept at 4. Our positive slope goes up 7 and right 6, or down 7 and left 6. The line will be a dotted line since there is no or equals symbol under the inequality. Now we will test the point 0, 0 to see if it makes the inequality true. Plug in 0 for x and y in the original inequality. 7 times 0 minus 6 times 0 is greater than negative 24, gives us 0 is greater than negative 24, a true statement. This means we should shade on the same side as 0, 0. All of the points in the shaded area make the inequality true. These points are the solution set of the inequality. In example 5, we begin by converting the equation to slope-intercept form. Subtract 12x from both sides of the inequality. This gives us 9y is less than or equal to negative 12x plus 36. Divide both sides by 9. We now have y is less than or equal to, simplify the slope for negative 4/3 x plus 4. To graph this line, begin at the y-intercept of 4. The slope is down 4 and to the right 3. This line will be a solid line since it has an or equals under the inequality symbol. Once again, we'll test the point 0, 0 to check for whether it makes the inequality true. Start with the original inequality. We get 12 times 0 plus 9 times 0 is less than or equal to 36. Or 0 is less than or equal to 36. This is true. So shade the same side as the point 0, 0. All of the points in the shaded area and the line are our solution set for this inequality. Pause the video and try the next example yourself. Now that you have tried it, check your work. Begin by converting the equation into slope-intercept form. Add 5x to both sides of the inequality. This gives us 10y is less than 5x plus 30. Now divide both sides by 10. This gives us y is less than 1/2 x plus 3. The y-intercept is 3. The slope is up 1 to the right 2. This will be a dotted line since the inequality does not include an or equals symbol underneath it. Now we should test the point 0, 0. Plug in a 0 for x and a 0 for y to give us negative 5 times 0 plus 10 times 0 is less than 30. 0 is less than 30 is a true statement. So our inequality is true on the same side as 0, 0. Shade this side. All the points on the same side that we have shaded are part of the solution set. The dotted line is not part of the solution set. In example 7, there is only an x in the equation, no y. Let's simplify it by dividing both sides by negative 3. This reverses the inequality, giving us x is greater than negative 4. Anytime we have a line that only includes x and no y, we have a vertical line. This is a dotted line since it does not include an or equals under the inequality symbol. Now we need to test a point. Once again, we'll test 0, 0. We can plug in 0 for x, but there is no y, so we don't need to worry about it. 3 times 0 is less than 12, gives us 0 is less than 12, a true statement. Shade to the right of the line. All the points in the shaded area make the inequality true. In the last example, the inequality is already in slope-intercept form. The y-intercept is 0, and the slope is up to right 3. We will draw a solid line because there is an equal symbol under the inequality. Now we need to test a point. Unfortunately, the point we usually use, 0, 0, is on the line, so we need to test another point. In this case, I'm going to choose a 3 for x, since that will cancel out the denominator and make that multiplication easy, and a 0 for y. Plug in the 3 for x and the 0 for y, so that we get 0 is greater than or equal to 2/3 times 3. Cancel out the 3's. This gives us 0 is greater than or equal to 2, a false statement. Thus, we will not shade this side, we will shade the other side. All the points in the shaded area make this inequality true. The shaded area plus the solid line is the solution set. In conclusion, let's remember all the steps we've used for solving linear inequalities. First, we rewrite the inequality into slope-intercept form. Then we draw the line. If there is an equal symbol under the inequality, we draw a solid line. If there is not an equal symbol under the inequality, we draw a dotted line. Then we choose a point to test. If that point makes the inequality true, we shade on the same side as that point. If that point makes the inequality false, we shade on the other side. The shaded area is the solution set to the inequality. The solution set includes a solid line and does not include a dotted line. Please refer back to these notes often as you complete your homework. Thank you.